Okay, let's continue with the second learning outcomes. This is about environmental consequences if you burn the hydrocarbons, okay? And then how to remove the pollutants and how to use the infrared spectroscopy in monitoring air pollution. Okay, every combustion will release gases, okay? But the worst come if the incomplete combustions occur. In incomplete combustion, the alkene react with limited amount of oxygen. So this will produce CO as the products, or CO, H2O. Yeah, it can be CO, H2O. It can be C plus CO with H2O, or it can be C plus H2O only. Okay, so the alternative would be C or CO. The focus here is the presence of CO is very, very dangerous, since CO is very toxic for human. Okay, why carbon monoxide is very toxic? Okay, since it can make a very strong bond with hemoglobin. What is hemoglobin? Hemoglobin is the protein in our red blood cell. Yeah, that has a responsibility to carry oxygen to all organs in our body. Okay, since carbon monoxide replace oxygen, to bind with the protein in our red blood cell. So instead of transport oxygen, it will transfer the carbon monoxide. So that means the body will not receive oxygen. The victims will feel dizzy, lose consciousness, and then if not removed as soon as possible, the victim will die. Okay, carbon monoxide is very dangerous since it is odorless. Yeah, so sometimes people don't realize that the carbon monoxide present. Okay, this is that's why sometimes people can die unexpectedly. Yeah. Okay, you can see from this diagram that carbon monoxide binds very tightly to hemoglobin, so oxygen can no longer be carried. Okay, the second pollutant that dangerous is nitrogen oxides. Okay, the traffic also releases acidic nitrogen oxides. Why it is called acidic? Since it can make acid rain, can make acid rain. And you know that acid rain will kill trees, aquatic animals, corrodes metals such as iron, etc. In normal combustion, nitrogen gas in the air does not get oxidized. However, in very high temperatures in car engines, the oxidation of nitrogen can take place. So N2 plus O2 becomes NO here. This is occur in the very high temperatures, in the car engines. Okay, and then I hope you already ever read chapter 13 about nitrogen and sulfur. But if you never read this chapter, I'd like to give you information that nitrogen monoxide here can undergo further oxidation to form nitrogen dioxide. Now you can balance this 2 and 2. Okay, further oxidation to form nitrogen dioxide. Nitrogen dioxide react with water and oxygen to form a very strong acid that known as nitric acid. You can balance this 2, and this is half. 2 each, 2 and 6O. Okay. This is why the acid rain occur, because it's NO3 formed by reactions of NO2 with H2O. So this is called as the direct formation of acid rain. Once again, because of nitrogen monoxide undergo oxidation to form nitrogen dioxide and then combine with water. But it can also make the acid rain yeah, affect the acid rain, but indirectly. What that means indirectly? Fuel and coal also produce sulfur, yeah, as the other pollutants. Sulfur can burn in oxygen to form SO2. You know that SO2 is also the pollutants to form acid rain. Okay, but I want to focus on how nitrogen monoxide or nitrogen dioxide, yeah, give impact to formations of acid rain indirectly. Okay, this is by oxidize SO2 to SO3. How to do this? SO2 will react with NO2. So NO2 behave as an oxidizing agent since it will give oxygen to SO2 to form SO3 with NO. So NO2 is a catalyst, yeah, in this case. Yeah, catalyst to oxidize SO3. Next, SO3 will combine with H2O to form a very strong acid H2SO4. So that's why this is called as indirectly method of how nitrogen dioxide gives acid rain. Okay, this is by oxidize the SO2 to SO3. Okay, indirectly affect. This is directly affect. Why it is called catalyst? Since NO that produced, yeah, in these reactions can reform to form NO2 by, yeah, oxidation again, yeah, to form NO2. So that's why this is called as catalyst, because it can reform, yeah, at the end of the reaction. So this like a cyclic, yeah, it can react again, and again. Okay, so far we already learned about CO as a pollutant, toxic because it bind to hemoglobin. And then the second one is nitrogen monoxide, yeah. Nitrogen monoxide, nitrogen dioxide form acid rain and oxidize SO3, yeah, SO2 to SO3 to form acid rain as well. So already two pollutants. Okay, this is the third. Volatile organic compounds. Okay, sometimes, yeah, the unburned hydrocarbons will be released, yeah. So not all petrol will be undergo perfect combustion reactions, yeah. Some of them will unburn. So it can, and then since it is volatile, it can release to the atmosphere, yeah. So called as volatile organic compounds or VOC, and this is very dangerous since they are carcinogenic, yeah. They cause cancers. Okay, so far we already learned about CO, and then you remember nitrogen oxide, yeah, and then the third is VOC, volatile organic compounds. How to prevent or how to reduce the pollutants? Yeah, cars nowadays, yeah, will be use a catalytic converter. Catalytic converter is made from transition metals such as platinum or palladium or rhodium, yeah, and then cover with beads, yeah, to improve the surface area. Okay, and then the catalytic converter will convert some pollutants, yeah, such as CO and NO, yeah, to form a less harmful gases. Carbon monoxide will be oxidized to form carbon dioxide. And then nitrogen oxides will be reduced to form nitrogen gas. You know that N2 is not harmful, right? And then number three, the oxidations of unburned hydrocarbons to form carbon dioxide and water. So three gases will be removed using this catalytic converter: CO, nitrogen monoxide, and unburned hydrocarbons. Yeah, unburned hydrocarbons. So this is the catalytic converter look like. Yeah, use precious metals such as platinum. Okay, and then this is the equation of how the very toxic gas changes to the less harmful gases. CO changes to CO2, NO changes to N2. How about unburned hydrocarbon? it changes to CO2 and H2O. Yeah, don't forget the third one. Yeah, the unburned hydrocarbon changes to CO2 and H2O. Okay, the fourth pollutants that we will learn here is CO2. You know that CO2 actually is not too harmful, yeah, for human being, but it is very affect to the environment since CO2 traps more heat, yeah, known as global warming, yeah, global warming. It raises the temperature of Earth. You know that CO2 actually is the natural gas, yeah. It's try to trap heat from sun and then makes the heat the earth becomes warmer, yeah, since if not the temperature of earth will be very full, yeah, if there is no sunlight. Okay, so this is naturally occur, but the human being activity sometimes increase the CO2, yeah, very high. So you can see that, yeah, before the greenhouse gases like this, yeah, only this thick, but because of human activity, yeah, it increase of the thickness. So that's why if the sun gives heat, yeah, actually the earth should yeah, remove the heat again, okay. But since a very thick greenhouse gases layer, the heat cannot escape from this uh, layer, yeah, from this greenhouse gases layer. So it will turns back to earth, yeah. What happened with the temperature of the earth now? It will increase, yeah. Yeah, supposed to be released to the space, but this is turns back. So that's why ice in pole could be melted, okay, and then float everywhere, yeah, etc. That's the effect of greenhouse gases. Okay, about infrared spectroscopy will be learned in chapter 18, yeah, during aldehyde and ketones. But I just want to introduce you about the use of this spectroscopy to monitor the air pollution. Okay, so sometimes the scientists can get the samples of air, the pollutions on air in air, and they can then they can observe, yeah, the numbers of pollutants, yeah, through the spectroscopy method called as infrared, yeah. So the intensity will represent the concentrations of pollutants, yeah, in the sample. So if you monitor over the period of time, the scientists can be think the effective ways, yeah, to reduce the pollution. Okay, because of infrared spectroscopy can detect a very small pollutants, yeah, and it is very precise, yeah. Okay, now let's practice. This one, your answer. Okay, this is A, yeah. Carbon monoxide, hydrocarbons, and nitrogen oxides. It will not remove the sulfur dioxide, yeah, please remember. Will not remove. And also not carbon dioxide, yeah. Okay, please pause this video while you're working to answer this. Okay, let's discuss. State 3 more pollutants other than CO2 and H2O that are present in the exhaust gases of a car engine. What's it? What is it? 3 more pollutants other than this and this that present in exhaust gases. Okay, it can be SO2, it can be NO2. It can be CO, or it can be hydrocarbon. Yeah, but you just need to state three. Yeah, or it can be carbons. Yeah. What is the active material present in the catalytic converter? It is platinum or palladium or rhodium. Yeah, rhodium. Write one balance equation to show how NO is removed from exhaust gases of car engine by catalytic converter. NO plus CO, N2 plus CO, CO2. Balance this. Okay. If you are correct, all correct, 4 points. Yeah. Okay, next question. Okay, the answer is D. Okay, nitrogen dioxide causes acid rain if it is released into air. Removed from car by catalytic converter. It is nitrogen dioxide. How about this? The catalytic converters fit to cars remove pollutants from exhaust gases. Some of the reactions that occur involve oxygen, which comes from the air. These pollutants in the exhaust gases will react with oxygen on the surface of the catalytic converter. NO2. This is already oxidized, so will not react with oxygen. Unburned fuel, yes, yeah. CO, yes, yeah. So the answer is 2 and 3. C. Next question. With pollutant present in the exhaust fumes in an internal combustion engine has an element of +2 oxidation states and odd number of electrons in the one molecule of the pollutant. Okay, you can see that this is +2, this is -2. So we'll note this. This is +2, this is +4, and we'll note this. So between A or C. But which one has the odd number of electrons? Okay, let's try to make the structure of CO. You know that it makes a double covalent bond with oxygen and then one negative bond with oxygen. Yeah, you can see here 1, 2, 3, 4, 5, 6. This is the CO molecule. So all electrons in pairing condition. How about NO? Okay, N has 5 valence electrons. So two making covalent bonds, yeah, to make covalent bonds with oxygen, double covalent bonds, and then you can see that it has odd number of electrons. Okay, so NO is the answer.